NASA's new ISS module, a technological leap and a bold statement. NASA has just revealed a new addition to the International Space Station, and experts are calling it one of the most advanced modules ever constructed. But this isn't just about breaking technological barriers. There's a twist that could redefine how we think about space exploration and its implications for life on Earth. Imagine a future where events hundreds of miles above our heads could alter the way we tackle issues on the ground, from climate monitoring to global communications. Here's the reality. NASA's latest ISS module isn't just designed to enhance space research, it could change everything. And this development isn't happening in isolation. It's unfolding during a time of heightened tensions in space exploration, with global powers and private companies racing to establish dominance in space. Why does this matter now? Because the stakes are higher than ever. What's inside this module could shape our future, whether we're ready for it or not. The latest addition to the ISS is more than a module. It's a bold statement about the future. What's at stake is nothing short of our role in space and our ability to harness technology to face unprecedented challenges here on Earth. Stay with us as we unpack the mystery and purpose behind NASA's latest move and why it might just blow your mind. Chapter 1: A Turning Point in Space Exploration. This latest ISS module isn't just a technological marvel. It's the culmination of decades of breakthroughs, challenges, and perhaps some unsettling unknowns. For years, space agencies like NASA and private giants like SpaceX have been pushing the limits of human ingenuity to establish a permanent foothold in space. Yet, along with these advancements, a new era of space dangers has quietly emerged. Just a few years ago, concerns about overcrowding in Earth's orbit grew as satellites and debris began to cluster in alarming numbers, raising fears about catastrophic collisions. NASA's scientists have warned about the Kessler syndrome, a chain reaction of orbital collisions that could make sections of space unusable. This new module, while groundbreaking, is designed with more than just research in mind. It must also contend with a highly volatile environment where any minor miscalculation could threaten the ISS itself. NASA and its partners have developed this module to navigate a growing list of threats: rising tensions with other spacefaring nations, unpredictable cosmic events, and even the potential for man-made disasters. Why now? Because time may be running out. As countries ramp up their efforts to dominate space, this module represents both a shield and a gamble. The reality is that no one knows for sure what lies ahead. This innovation may be NASA's biggest leap yet, but could it also be their riskiest move? The answer may lie in a surprising twist that could change how we look at space exploration forever. Chapter 2: The ISS Module Redefining Space Innovation. NASA's latest module, known as the Haven Orbital Laboratory, is like nothing we've seen before. It's not just an expansion of the International Space Station, it's a complete reimagining of what a space module can be. While previous modules focused primarily on functionality and survival, Haven is outfitted with cutting-edge specialized facilities that allow astronauts to conduct advanced experiments with unprecedented precision and control. Inside, the module hosts next-generation labs dedicated to genetics, physics, and deep space simulation. Equipment so precise it can detect molecular changes at the cellular level in real time will be pivotal in studying how prolonged exposure to space affects the human body, critical as we look toward longer missions. Unlike any previous ISS edition, Haven is equipped with radiation-shielded chambers designed to protect both astronauts and sensitive equipment from space's most dangerous rays. For the first time, astronauts can work in an environment where radiation levels are carefully controlled, allowing for longer, safer mission durations. But the advancements don't stop at science. This module offers unprecedented onboard comforts, from sleep pods tailored to counter zero-gravity stress to adaptive lighting that helps regulate astronauts' circadian rhythms. These small luxuries aren't just for comfort, they're strategic, aiming to reduce the mental and physical toll of extended missions in space. Perhaps the most groundbreaking addition is Haven's AI-driven system, specifically built to monitor and adapt the module's environment in real time. From predicting potential hazards to adjusting oxygen levels, this AI is essentially a silent partner in every mission. However, with all these high-tech features comes an equally high level of risk. Can Haven handle the intensity of deep space, or will this leap in technology also expose astronauts to unforeseen dangers? NASA's Haven Orbital Laboratory is more than just a leap in technology. It's a move that could redefine humanity's relationship with space, with impacts stretching from orbit to everyday life on Earth. This groundbreaking module has given experts a glimpse into how space innovation can benefit global health, climate science, and even cybersecurity. For instance, the Advanced Genetics Lab could uncover new treatments for diseases by studying how human cells respond to prolonged space exposure, potentially transforming healthcare on Earth. On a broader scale, Haven's enhanced Earth monitoring systems are designed to track environmental changes with unmatched precision, potentially giving us critical real-time data on climate shifts. This technology could revolutionize disaster prediction, giving us earlier warnings about extreme weather events and saving lives and resources worldwide. But it's not all opportunity without risk. Haven's AI system, a marvel in autonomous tech, raises questions about dependency on artificial intelligence in high-stakes environments. If this system fails or is breached, the safety of astronauts and even Earth-based systems connected to it could be jeopardized. This module represents the first time such AI has been trusted with life-sustaining functions in space, and experts warn that any malfunction or interference could lead to dire consequences. These advancements have drawn unprecedented alliances between NASA, tech giants, and international space agencies, uniting them in a race to push human capabilities beyond Earth's boundaries. Chapter 3: The High Stakes of Humanity's Frontier. NASA's Haven Orbital Laboratory represents a pivotal moment that could reshape our future. Success would mean new frontiers in medicine, environmental protection, and space exploration. With insights from zero-gravity research, diseases could be treated in ways we once thought impossible, and environmental data from space could enable us to predict and mitigate climate disasters with newfound accuracy. This technology has the potential to improve life on Earth and extend humanity's reach beyond our planet. But if Haven falters, the consequences could set space exploration back by decades. A malfunction in this high-stakes module wouldn't only risk the lives of astronauts but might also force us to reconsider our future in space. The limits of autonomous systems and ethical considerations. To question the limits of autonomous systems and AI in life-critical environments is to challenge the trust humanity is placing in technology. This trust has no precedent, and a setback could cast a long shadow over future missions. Moreover, Haven's success would set new ethical standards around data privacy and safety, impacting not only astronauts but citizens on Earth. With its constant environmental monitoring and AI-driven decision-making, this module is pushing the boundaries between global safety and personal privacy rights. If this mission redefines collaboration between private companies and global powers, it also establishes new layers of responsibility for our shared future. Chapter 4: Expert Analysis and Future Projections. Experts are closely analyzing NASA's Haven Orbital Laboratory, weighing its groundbreaking potential against significant risks. Data from space analysts suggest that if Haven succeeds, Earth monitoring capabilities could increase by 30% within the next 5 years, transforming disaster response, agriculture, and resource management globally. Dr. Elaine Rivera, a senior researcher at the International Space Policy Institute, notes that Haven's capabilities could revolutionize how we monitor climate, predicting natural disasters days in advance and saving thousands of lives. On the medical front, the genetics lab aboard Haven may enable discoveries in combating degenerative diseases, potentially leading to treatments worth billions of dollars annually. However, a misstep could have equally far-reaching consequences. Dr. Alan Roth, an aerospace engineer with the Global Space Coalition, warns that relying on AI-controlled systems in such a critical environment is unprecedented and could lead to cascading failures if even a minor error occurs. Roth emphasizes that a single failure in Haven's automated systems could create a chain reaction, endangering astronauts and derailing ongoing research. In a worst-case scenario, Haven's AI might misinterpret data in a way that requires a full mission shutdown, setting back space research and risking lives. Predictions about broader societal impacts are just as complex. A successful Haven mission could drive investment in AI and space research, sparking a new wave of technological advancements across industries. However, success on this scale also raises ethical concerns about surveillance capabilities and privacy, especially as space agencies and private firms share an unprecedented level of data. Experts caution that unexpected results could arise. Increased dependency on AI might lead to critical vulnerabilities, or new findings in space could reshape health industries, fueling debates on access and ethics. Chapter 6: The Edge of Discovery, Unknowns and Possibilities. With Haven operational, the stage is set for both groundbreaking discoveries and unforeseen challenges. Scientists are on the brink of new data that could redefine our understanding of space's effects on human biology. But there's a catch. Initial readings from Haven's genetics lab have shown unexpected fluctuations, leaving experts scrambling to determine if these are early breakthroughs or troubling anomalies. Could this be the start of a new scientific era, or are we seeing hints of deeper, unresolved issues? Meanwhile, Haven's AI-driven systems, responsible for maintaining life support and environmental controls, have been performing well under pressure. However, NASA engineers are closely monitoring for even the slightest irregularity, knowing that a single miscalculation could spell disaster. So far, the AI has shown remarkable resilience, adapting to slight atmospheric changes with precision. But every decision made by this system raises a critical question. Can we continue to entrust our most advanced missions to a technology that even experts admit they don't fully understand? As the module pushes the boundaries of exploration, new obstacles emerge. Cosmic radiation levels have risen unexpectedly, pressing scientists to find ways to reinforce the module's shielding in real time. The team has suggested a possible workaround involving magnetic fields, a concept that, if successful, could revolutionize future space travel. Yet the risk is enormous, and failure here could expose astronauts to dangerous levels of radiation. The Haven mission teeters on a knife's edge, where each new insight reveals both a glimpse of success and a potential threat. With critical decisions ahead, the next phase promises revelations that could either bring us closer to answers or plunge us deeper into the unknown. Chapter 7: Challenges on the Horizon. As NASA's Haven Orbital Laboratory embarks on this groundbreaking mission, several obstacles threaten to derail its success. One of the biggest challenges lies in the political landscape. Nations worldwide are vying for dominance in space, with some rivals viewing NASA's advancements as a direct threat. This has sparked debates about resource allocation and competition for orbital real estate, creating potential tensions that could affect international cooperation on future projects. Yet this rivalry might also spark unexpected alliances, as spacefaring nations realize the benefits of shared knowledge and resources in such high-stakes missions. Technical hurdles are just as pressing. Haven's reliance on advanced AI for mission-critical functions introduces a level of risk never before attempted on this scale. Engineers are racing against time to refine fail-safes and ensure that the AI can adapt to unpredictable conditions in space. This pressure has driven NASA to explore unprecedented solutions, possibly unlocking new technology that could shape the future of autonomous space exploration. Budget constraints add yet another layer of difficulty. Each new innovation adds millions to an already strained budget. While these limitations may seem restrictive, they've also led NASA to work with private companies in groundbreaking ways, fostering innovations that likely wouldn't have emerged otherwise. These partnerships could set a new standard for collaboration between public agencies and private space enterprises. But with all these challenges mounting, one question looms larger than ever. Can Haven overcome these obstacles to unlock the mysteries of deep space? Or will these hurdles be the undoing of one of NASA's most ambitious projects yet? The fate of the mission. With the mission's fate hanging in the balance, the stakes have never been higher. Will NASA's efforts reshape our future or reveal that the cosmos is more untamable than we ever imagined? Stay tuned for updates on this historic journey, where every discovery could change life as we know it. The story is far from over.